Okay, so today we're going to fill in this properties chart so that you kind of have a guide and a list of all the properties so that as we're practicing these, then you've got something to refer to. But you're going to have to be able to do this on your own on the quiz for you guys Tuesday. Okay? All right, the first property is the commutative property of addition. Now, I'm going to give you the definition. That's going to go in the first column, but I'm also going to give you a hint and an example when I can, so it's something to help you remember it. Now, commute. If you commute to work, you're moving from home to work, right? So commute means to move or change the order. So the commutative property of addition says you can change the order and the answer is still the same. So if I add 3 plus 5, it's the same thing as adding 5 plus 3. Both answers will give me 8. So we have the commutative property of addition, and we also have the commutative property of multiplication. So this says that you can change the order when you're multiplying, and it doesn't change the order or doesn't affect the answer. So we all know that if I take 7 times 4, I'll get 28. Whoops, I just wrote the same thing. Take 2. But 4 times 7 is also 28, right? This was really helpful when you were in elementary school when you're learning your math facts, right? Because as you got through them and then you already did the mastered the 3s, when you got to 7s, you already knew the 7 times 3, right? Because you mastered them in the 3 level. All right, so that's commutative. Change the order. Associative. If I talk about who you associate with, that's what groups of people you associate with. So that might be people that go to Aquinas, people that go to your parish, people that live in your neighborhood, people that play football together, they associate with. So this is the group. So on the associative property, we're going to change the groups. So anytime we change the groups, we're talking about the associative property. So if you look at the definition I gave you in the first parentheses is B plus C, and the second one is A plus B. So we've definitely changed what's in those groups. So for example, I can take 7 and add the quantity 3 plus 5, and that will be the same thing as if I did 7 plus 3 first and then added 5. This is helpful when you're adding a chain of numbers. You can group them any way you want to help you add. Now notice the order didn't change. It still says 7, 3, 5, and over here it says 7, 3, 5, but what's inside the parentheses, the order has changed. Okay? The groups have changed. So you can change the groups when you add, and you can change the groups when you multiply, and it's still going to give you the same thing. Okay, so if I take 6 times the quantity, 4 times 2, it'd be the same thing as taking 6 times 4 and then multiplying that quantity by 2. Same thing. Okay, that's the associative property. So notice I'm changing what's in the group. So in this group, there was a 4 and a 2 on the left. And on the right, the group has a 6 and a 4. Okay, additive inverse. The additive inverse is when you add the opposite to something and you get 0. So the additive inverse is adding the opposite. So for example, I can have negative 10W and add the opposite, positive 10W, and my answer will always be 0. When you add the opposite, you will get 0. Now, it doesn't work like that with multiplication. We don't have the same kind of effect. So with multiplication, when we're talking about the inverse, we're talking about the reciprocal. So the multiplicative inverse, you multiply by the reciprocal and you get 1. If you multiply by the reciprocal, you will get 1. So if I have 3/4 and I multiply it by its reciprocal, what's the reciprocal of 3/4? 4/3. My answer will always be 1. So the additive inverse is the opposite. The multiplicative inverse is the reciprocal. Okay, next we have the identities. So the identities say what can we add to a number to not change its value? What can we add to any number and not change the value? 0. Okay, so the additive identity says you can add 0 and it's not going to change the value whatsoever. Okay, so on this one, if I have 9x and I add 0 to it, it's still going to be 9x. Now when I multiply, if I multiply by 0, that's going to change the value. But what can I multiply by to not change the identity? 1. So the multiplicative identity says I can multiply anything by 1 and it doesn't change the value. So if I take 4 and multiply it times 1, I will still get 4. It doesn't change the value. So the identity is what you can do to something to not change the value. Okay, the distributive property, you shouldn't really need help on it. You've done this so many times. Now, a big red flag that makes the distributive easy to spot is that there's only one parenthesis. So if we have 3 times the quantity x plus 4, you will get 3x plus 12. Okay, the next property is the reflexive property that says a number equals itself, okay? Which for right now doesn't do us much good, but when we do the triangle proofs a little bit later, it's going to be helpful. So if I say I've got 7k, it will equal 7k. So a number equals itself. Okay, the next two are the only two that are written in an if-then form. So if you see something in an if-then form, you can immediately jump to one of these two things. The first one is the symmetric property. And you use the symmetric property all the time. You just don't realize that it's got a name. If you solve an equation at the end, you get 2 equals x, you automatically write it x equals 2 because you can. Okay, it's changing the side of the equal sign that you're on. So if x equals 2, then that's the same thing as 2 equals x. You can change the side of the equal side it's on and it's still the same thing. So the symmetric property is an if-then statement and it deals with 2 things. The transitive property is an if-then statement and it deals with 3 things. Okay? So this is kind of a duh when you see it, but if you know that x equals 2 and 2 equals y, then what do we know about x and y? They're equal, right? Okay, good news. The fun isn't over. There's a couple more on the back. So when you get this done, flip it over to the back. Okay. Now, you use these things all the time when you solve equations, but later when we're going to do algebraic proofs, we need to be able to justify our steps. And so we're going to use these for the different steps. The first one is the addition property of equality. So if 2 things are equal, then you can add the same thing to both sides of the equation and it'll keep it balanced. So if I have x plus, excuse, just kidding, let me write that again. If I have x minus 3 equals 7, then I can write, whoops, hold on. Then I can write x equals 10, right? Because what did I do to both sides of the equation to go from here to here? What did I do? I added 3. Didn't I add 3 to both sides and kept it balanced? That's what's going to happen in our proofs, because when we do our proofs in a little bit, we're not going to show our work. We're going to have to do it in our head like that. Okay, so then you can guess the subtraction property of equality. So if two things are equal, you can subtract the same number from both sides, and it'll all work out okay. So if I have y plus 9 equals 11, then I can write y equals 2. Because what did I do to solve that equation? Subtracted 9 from both sides. Okay? And you can probably figure out the other two. The multiplication property. Okay? So if both sides are equal, I can multiply both sides by the same number, and I'll get the right answer. Okay, so in my equation, if I have x over 3 equals 5, then I can say x equals 15. How did I go from the first step to the second step? I multiplied both sides by 3, didn't I? Okay, one last one. The division property, which is pretty much the same thing, but there's one little exception. If the two sides are equal, but c is not 0, because can we divide by 0? No. So if the two sides are equal and c is not 0, then you can divide both sides by the same number, and it all works out. So if I have 3x equals 12, then I can write x equals 4, because didn't I divide both sides by 3? Okay, I'm going to put some properties up here. You do not need to write them down. I just want you to use your chart and see if we can identify what property it is, okay? So don't write them down, just look at your chart and look. Okay, number 1. What property is number 1? Distributive. Okay, that's the easiest for people to recognize. Okay, number 2. Number 2, we added the opposite and got 0. What's that? Additive inverse. Very good. Number 3, I changed the order in which I wrote the 7a and the 9. What's that? Commutative of addition. And again, like the names of the angle pairs, I'm okay if you abbreviate as long as the abbreviation makes sense. With the commutative and associative, you have to tell me of addition or of multiplication with it. Okay, 4 is an if-then statement and involves two things. What's 4? Symmetric. Okay, number 5, we multiplied by the inverse and got 1. What's number 5? Multiplicative identity. Good. Number 6. Now, number 6 confuses people because they see the parentheses and think it's the associative property. But the associative property says you change the groups. Now, let's look at this. This says 2x minus 7, and that says 2x minus 7. Did I change the groups? Not at all. What I changed is the order in which the 4 was written. Here it's written on the left, and here it's written on the right. So when I change the order, what property is that? Commutative, and this is of multiplication because I changed the order in which I multiplied the 4, right? Now, if you compare 6 and 7, here I have 3 times x, and here I have 4 times 3. Okay, now have I changed the groups? So 7 is what? Associative multiplication. Very good. And last but not least, 8 is an if-then statement with 3 things. What's 8? Transitive. Okay, now, I'm going to give you a couple of these properties, and you can use your chart to practice. Okay, let's check these and see how you did. The first one, there's the one parentheses, so that tells you it's the distributive property. Number 2, there's parentheses on both sides, so you look. One parentheses had 3 plus x, the other had x plus 8, so they definitely changed the groups. So 2 is associative property of addition. 3, they multiplied by the inverse, so it's the multiplicative inverse. 4, they changed the order of those numbers, so it's commutative of multiplication. 5, added the opposite, so that's the additive inverse. 6 tricks people, but on number 6, look at the parentheses. This one says 3x minus 7, and this said 3x minus 7. Did they change the groups? No, they just changed the order in which the 8, so that's commutative multiplication. 7 is another distributive property. 8, you're changing the groups, because this one is 5x, and this is 6 times 5, so it's the associative property of multiplication. 9, multiplying by the inverse, so it's the multiplicative inverse. 10, adding the opposite, so it's the additive inverse.